Today we're talking about inverse trig. Inverse in math means a way to undo things. So we have to have a way to undo everything that we do to numbers. If I multiply, I can undo that. If I add, I can undo that by subtracting. If I square, I can take a square root. We always have a way to undo what has been done to a number. So if I apply a sine or a cosine or a tangent, I need a way to undo that trig function. And this is what's called inverse trig. It is also called arc. So if you see arc sine, that means the inverse sine. Our notation for inverse is the same as the notation that we used back in the last chapter when we learned about inverses, and that's this little -1. Okay, that's not an exponent. That means that what we're asking for here is the inverse function of sine. The way I think about these questions is kind of like Jeopardy. So in the last assignment, I gave you something like sine of 45. And your job was to come up with the answer for that, which would be 1 over square root of 2. Today, in this lesson, I'm going to give you the trig function, so that's like our category, and I'm going to give you the answer. And your job is to come up with the question, kind of like Jeopardy. Okay? Inverse trig, the answer is an angle. So when we're looking for an angle for our answer, that's when inverse trig is applied. It is important that you know your key pictures that we've talked about and looked at, because that's where our answers are all going to come from. So one of those pictures was our unit circle. Pretend like this is centered. And we had our 4 points around the edges. And those work for 0, 90, 180, and 270 degrees going around our circle. And remind me, what do those points mean in terms of trig? In what order? Cosine, sine. It's alphabetical. Okay, alphabetical just like x, y. Okay, so that picture is going to be important to us today. Another picture that's going to be important to us today is our 30, 60, 90 triangle, which has sides of 1, 2, and square root of 3. And the third picture that's going to be important today is our 45, 45, 90 triangle, 1, 1, square root of 2. So that means we have a very limited set of answers that will be possible for these questions, because everything has to come from the angles in these pictures. So that means there's 4 different angles around our circle. Then from our triangles, we can have 30 or 60 or 45. We cannot pick 90 from a triangle.
Mr. Ayers?
Yes?
Can you send Lydia Dykstra down to the office?
Yep.
Thank you.
We cannot pick 90 from a triangle. If 90 is an answer, it's coming from the circle. Okay. The reason why 90 doesn't work in triangles is because in a triangle, 90's opposite is the hypotenuse, so that would cause some problems. Okay. So what we're going to do in each question is first think about some SOHCAHTOA. So the first question, we're working with the sine function. What's SOHCAHTOA for sine? Opposite over hypotenuse. So SOH, opposite over hypotenuse. So then we line up the parts of the fraction that is opposite of a square root of 3 with a hypotenuse of. So where do I find a hypotenuse of 2? 30, 60, 90 triangle. And now in the 30, 60, 90, which angle is opposite of the square root of 3? The 60. So 60 is our answer. The directions say to evaluate in both radians and degrees, so we need to turn this into radians. When we learned our conversion for radians, just like 12 inches is a foot, we said that pi radians is 180 degrees. So how many times does 60 go into 180?
Pi over 3.
3 times, so we get pi over 3. Okay, so we think about first SOHCAHTOA, sine is opposite over hypotenuse. Then we try to locate that in a triangle. A hypotenuse of 2 opposite of the square root of 3 gives the 60. For the next one, We can write anything as a fraction, so I can make this into over 1. Question?
Why is it not 30?
Because I want opposite of the square root of 3, so if I take the square root of 3 and go directly across from it in the triangle, I land at the 60. So, cosine. What's SOHCAHTOA for cosine? Adjacent over hypotenuse. So I need a triangle that has a 1 next to it. That's what adjacent means. And that has a 1 on the hypotenuse. So a triangle has a 1 on its hypotenuse. Neither one of them have 1 on the hypotenuse. Right? The hypotenuses, hypoteni, are 2 and square root of 2. Okay? So that doesn't work. That means we need another method. So if our answer is not working to look in the triangles, where do you think our answer is? In the circle. So if your answer doesn't work in the triangle, in the circle, all the points are cosine comma sine. So if I have a cosine of -1, that means I have the first part of the point. I don't know what the second part of the point is. As the first part. Where is that located? At 180. At 180, we have a point that has a -1 as the first part. We don't care about the second part. And what is 180 in radians? Pi. That's our conversion. That's like 12 inches is 1 foot. 180 degrees is 1 pi radians. For the last one, you can make anything into a fraction. What's SOHCAHTOA for tangent? Opposite over adjacent. So I need a triangle that has 2 1s in it, and I don't care about the hypotenuse. Where's that? 45, 45, 90 has 2 1s in it, and I don't care about the hypotenuse at all, because hypotenuse is not a part of tangent. In the 45, 45, 90 triangle, the answer must be 45, because our angles are 45, 45, and 90, but you're not allowed to pick 90, so it's 45 or 45. So that's our answer. How many times does 45 go into 180? 4 times. So you get pi over 4. Questions? In the next problem, for the first part, we need to begin by unrationalizing our answer. I have been telling you to not rationalize your answers on your homework, but if you check the back of the book, they have been. And in some of your questions, you may have a rationalized version of a question. So, whenever you see a square root of a number on top and the same plain number on the bottom, that comes from 1 over the square root of the number. Okay, so I was asking you to not rationalize your answer, so your answer would have been something like 1 over square root of 2. But if you checked your answer in the back of the book, they would have been saying something like square root of 2 over 2. How did we fix the square roots on the bottom of fractions? We multiplied by itself, right? And if I did that, I would get that square root of 2 over 2. So they've cleaned up answers, and I asked you not to. And part of the reason why I asked you not to is because it's just something else to do, and it's not helpful once we get to inverse trig. We need it to be in its original form. And this is true for any numbers. So if you see square root of 3 over 3, that was 1 over the square root of 3. You won't see this because it's not a special number for us, but if you would see square root of 7 over 7, it was 1 over the square root of 7. Okay, anytime it's the same number, we can unrationalize it that way. So for this first one, work with instead 1 over the square root of 2, and then think about your SOHCAHTOA and locate the appropriate angles. Go ahead and work through these 3. So what's SOHCAHTOA for sine? So where do I have a hypotenuse of 2 with an opposite of 1? And 45 goes into 180 4 times. Pi over 4. For 0, I do not even need to bother thinking about triangles because there are no sides of zeros in triangles. 0 does not make much of a triangle. So whenever you have a 0 in a question, it must be coming from the circle. So in the circle, all the points are what?
0.
What order? Cosine, comma, sine. So if I know the sine is 0, that means I know the second part of the point is 0. So I don't care what the first part is, but I want the second part to be 0. That actually happens in 2 different locations. That happens on both our 0 line and our 180 line. So that means that our answer could be 0 degrees, which is 0 radians. That's what's considered the principal or the primary solution. But, I would also accept, won't move my screen, there we go. I would also accept 180, which is equal to pi, because that is also totally correct. I would even take 360 equals 2 pi, because that's still right. 360 is the same thing as 0, so it's still a true answer. Technically, the principal or the primary answer is 0, because that's the first answer we come across. But all of those answers are correct.
I get how we use the triangles and see how many times the number goes in, but I don't know how to use the circle. Where do we get 180 equals pi?
In the circle, we're looking for the point that has the given value in the right spot of the point. So all the points are cosine, comma, sine. So 0 goes in the sine location or the second location. So then we look for the point that has a 0 in the second location, which are the 2 points drawn up there. And those points, we take the angle of the line. So when we learned we graphed angles, we started here. So that means that angle is 0. If I go halfway around, that's my 180 line. So we're taking the angles of those axis lines. For the last one, what's SOHCAHTOA for tangent? Opposite over adjacent. So which triangle has 1s and square roots of 3s in it? The 30, 60, 90 has 1s and square roots of 3s. Students can find the 30, 60, 90 to be difficult to decide which angle we want. So I always group up my fraction. That top needs to match top and bottom needs to match bottom. So I need 1 to be the opposite. What is 1 opposite of? The 30. I like to look for opposites. I think it's easier than adjacents. But notice that that 30 is also adjacent to the square root of 3. So that still works as well. So our answer for this one is 30. And how many times does 30 go into 180? 6 times. I have one more question for you. What if I asked you for the inverse tangent of 0? Okay, well, it can't come from a triangle because it's got a 0 in there. So it must be coming from the circle. But in the circle, our points are cosine, comma, sine. So what about tangent?
Well, tangent is
Sine divided by cosine. So I'm going to turn this into a point, into a fraction. I can always divide by 1. That's a totally legal thing to do, is to always divide by 1. So that means now I want a sine value of 0 and a cosine value of 1. And they go alphabetically in our points. So where is that point? At our 0 line. Okay, so even the circle works for tangent. We just have to think about tangent being sine over cosine. For the next type of question, we're asked to find the measure of the angle. The measure of an angle is what inverse trig is used for. So according to that angle theta, what kind of a side is 5?
which
What kind of a side is 9? So which trig function would I use if I want an adjacent and hypotenuse? Cosine. So the cosine of the angle is equal to 5 over 9. Solving for an angle is what inverse trig does. So we are going to do the inverse cosine of 5 divided by 9. On your calculator, it is second cosine that brings up that inverse trig. So you're going to do second cosine of 5 over 9. So on my calculator, I press second, then cosine brings up that inverse cosine, 5 divided by 9, enter. You can close those parentheses or not close them since it's at the very end of a question, it doesn't matter. So we get about 56 degrees. The directions on this problem asked us to give our answer in both radians and degrees. So this is our degrees answer. To get a radians answer, I'm going to go into the mode menu, and on that third line down, make the word radian dark. Then if I go back to my home screen by pressing clear, I can just hit enter, and it'll reevaluate it now in radians to get 0.982 about. Okay? So our problems ask for both radians and degrees. We can recalculate it just by changing the mode. Questions? Yes?
Didn't you say that we can't use a calculator unless it says like estimate or something like that? We use a calculator.
Yes, you should only use a calculator if it says like estimate or approximate. I think these questions do in the book. But there's no way to do this without a calculator. You would have to do this with a calculator because 56 is not a special angle for us. Yes. And 12? So which trig would we use? Sine. So sine of theta is 7 over 12, which means the inverse sine of 7 over 12 will give us our angle. So on the calculator, we do a second sine of 7 over 12. And I was in degrees first, so that gave me right about 35.7 degrees. And then reevaluate in radians. Gives me 0.623 about. For our last question, it says solve the equation. Sine of theta is negative a fourth. So we're solving for theta. We want to know how big this angle is. And it tells us our answer should be between 180 and 270. So we are going to begin by evaluating that equation, doing an inverse sine of negative 1/4. I want my calculator in degree mode here since it tells me my answer should be between 180 degrees and 270 degrees. So we'll check our mode and make sure we're in degrees and do a second sine or inverse sine of negative a fourth. And I got negative 14.5. That is not between 180 and 270. So what that means I need to do is do some manipulating with this answer. If I graph the given answer, graphing negative angles, we learned the other day, goes around clockwise. So 14.5 would go right in here. That angle's in the wrong quadrant. I was told I wanted my answer to be between 180 and 270, which would be that third quadrant. You can reflect an angle into any quadrant you want, and the reference angle will remain the same. So I'm just going to flip this guy over into the quadrant I want it, and that reference angle remains the same. And our final answer wants to know how big The real angle is when I graph to this line. So we begin measuring from our 0 line all the way around to that angle would give me what? 194.5. 180 gets me halfway around plus that extra 14.5. You can check your answer in the calculator if you plug it into that original equation. So on my calculator, if I do sine of 194.5, you should get something reasonably close to negative 0.25. We did some rounding, so it's not going to be perfect, but it should be very close to negative 0.25. I think it's like negative 0.2503 or something, so that's very good. So begin by plugging it into the calculator and graphing. Then reflect it into the appropriate quadrant and measure around from that starting line. Go ahead and try the last one. So I begin by typing the given equation into the calculator, doing an inverse cosine of negative 2/3. And that gives me a starting answer of 131.8. But that is not between 180 and 270, so I have some work to do. So I graph the given angle. 131 degrees would be somewhere around in here. And I want to find how big that reference angle is, so I need to subtract from 180. So 180 minus 131.8 gives me a reference angle of 48.2. The answer is supposed to be in the third quadrant, though, between 180 and 270. So I'm going to flip the answer I have down into that quadrant, and the reference angle will remain the same. Then for our final answer, we measure from our starting line all the way around to that answer. So 180 of the half circle plus that 48.2 gives me 228.2. And you can check that in the original equation. If you take the cosine of 228.2, it should be reasonably close to negative 0.6 repeating. Your homework is from